Hello, everyone. Today is day 30 of coding every day. So it's pretty much been a month. Today's February 14th at 3 p.m. Today is a Friday. And today I will be looking at this problem here. So I'm doing this roadmap and I'm on graphs right now. So it's called rotting oranges. I looked at it a little bit. Okay, so rotting fruit. You are given a 2D matrix grid. Each cell can have one of three possible values: 0 empty cell, 1 fresh fruit, or 2 rotten fruit. Every minute, if a fresh fruit is horizontally or vertically adjacent to a rotten fruit, then the fresh fruit also becomes rotten. So the rottenness spreads to the fresh fruit. Okay, return the minimum number of minutes that must elapse until there are 0 fresh fruits remaining. If this state is impossible, return -1. Okay, so in my opinion, the first thing that I'm thinking to solve such a problem. Oh my gosh, you can have left click and right click. Oh, that's nice. Okay, so I'll use purple as rotten and orange as, orange as rotten and no, orange as fresh and purple as rotten. Okay, so if we have, let's say, oranges, fresh oranges here, and then we have a rotten one there, right? Something like this. And then these are just blank spaces like that. Okay. So I'm thinking from every I'd like to BFS from every position, from every rotten position at the same time. Alternatively, what I could do is do I could BFS from every point. So like this would be 1, 2, 1, 2, 3, 2 from this one. And then do it from this one and override any smaller ones we find. So it'd be 1, 2, 1 is smaller than 3, so we keep 1, 2 is smaller than 4, so we keep 2, 2 is the same and 3 is the same. And then from this one, 2 is smaller than 1, so we do 1, 3 is greater than 2, so we do 2, and everything else would be the same. And then once we have this, we just get the minimum elements. Sorry, the maximum elements. Yeah, so we could do that. The only problem is, let's say this was 4 and this was 3, and then we overwrite this one to 2. How would we store that 3 is the next most max? We would need to have O of n space for that. If we do it the other way, where we do so if we like do one step of the BFS from every rotten fruit, somehow I haven't done that before, but so what that would look like is, okay, we do one step here, so that's 1 and 1, then one step here, that's 1, and one step here, that's 1, and then we BFS from all of those. Oh, I think I would know how to do that actually. And then, so then from all of these, it would be 2, 2, and 2. And then from all of those. And what we could say is we can't revisit the same nodes twice. would that always work? So what I'm thinking you would do here is in your queue, all you would do is just add all 3 of these into your queue. And then because it's breadth first search, it'll do this one, then 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 this one. So if we do it this way, my only thing is I'm wondering if it's somehow possible where, so if we have like this, I just want to make sure that it's not possible to like go this way before we go this way. So in other words, when I'm assuming that this statement is true. When we visit a fresh orange, our first encounter with a fresh orange must be the minimum distance from a rotten orange. I'm assuming that's true. And I'm looking I'm seeing if that's somehow not true. But I think if we do it this way, it like where we put all of these in the queue to start, I think that my assumption would be true. But for instance, if we do it with just this one first, our assumption would not be true because, for instance, this would be 2 distance, and then when we encounter it for a second time, it would be a shorter distance. Okay, so I think what I'm going to do is add these 3, because I can't think of if we breadth first search, then our first encounter with a fresh orange must be the closest possible one. And let's look at okay, so I'll assume that for now. And let's look at the examples here. So example 1, we have 1 rotten fruit. 1 rotten fruit here, as shown by this diagram. So 1, 1, 0, 0, 1, 1, 0, 1, 2. So in the first like minutes, it spreads and then adds this one to the queue and this one to the queue. And then it explores its neighbors. This one's rotten, adds it to the queue, explores this one. Okay, so, but we do have to know, okay, so each node also, we're going to have to keep track of its like minute information. So these would all be minute 0 as like the starting ones. And then these would be minute 1. So it's kind of like the distance, same thing. And then whenever you explore a neighbor, you take its like your current node minute plus 1 for all the neighbors. So like all of these become 2, etc. So that was minute 1. This is minute 2. Then that goes to minute 3, and then that explores to minute 4, and then we output 4. Okay. All right, so I think I will do this. So essentially I want to have a queue. So let's import deck from collections, import deck. Okay, so that makes a deck for us, which is a data structure we can pop and add to both sides of it in linear time. So we want Q to be equal to, I could just say for I in range length of grid and for j in range length of grid of 0. So this will double for loop. And then if grid of ij equals 2, then we would like to q dot append left. Doesn't really matter in this case if we append left or append right, but just because it's a queue, I will append left in this case to keep it consistent. So we're going to append ij0. So this is a queue of rotting fruit. So queue of rotten fruits, and then rotten fruits is a tuple of row, column, and minute rotten. So we're going to append all of the rotten fruits that are innately rotten at minute 0. Okay, so this gets us our queue. And then we're going to just breadth first search. And let me just look at this example too before we get any more into the coding. I like to make sure the algorithm works for both examples. So let me just, why is it yellow? That's not, I'm panicking. Okay, there we go. So what do we do over here? Orange and purple. So this is 101. So 1, 0, 1, 0, 2, 0, 1, 0, 1. So in this case, and this is all nothing, right? What do they call it? Empty cell. So in this case, it's going to, oh yeah, and then, so what we need, also I was thinking, is we need to know if there's any fresh fruit left. Because if there is at the end of the breadth first search, then we know to return -1. So I'm wondering if we can have a set called maybe fresh fruit. And then we can say if grid of ij equals 1, then we can say fresh fruits dot add ij, so the tuple ij. All right, so this will be here, and then set of fresh fruits. So every time we turn a fresh fruit into rotten, we can remove it from this set, and then at the end of our BFS, check if the length of this set is greater than 0, and if it is, we can return -1 because that means there's fresh fruit that have not been turned rotten. And here we can add elif. Okay, looks good. I could also append, I don't normally do it like this, but I could make a set called like empty, and then when I check the 4 cardinal directions, I can check if it's in empty, but I feel like that's just a waste of memory because we can just check. I think I also might be able to do this so without using a set, we might just be able to do fresh fruit counts, and every time we encounter a fresh fruit, we can lower the integer by 1, because really the only aspect of this set that we need is its length. So to be more efficient with memory, we can do that later on, but I'll keep it like this for now and not get too caught up in the details. Okay, so to do a BFS, we're going to say while queue. So this will keep popping from the queue until it's empty, basically. So what we want is the row, the column, and the minutes. So remember, this is a queue of tuples, so this will unpack the tuples. And then we'll say for delta R, delta C in each of the directions. So we'll do left, up, right, down. So left is same row -1 column, up is -1 row, same column. Right is same row +1 column, and down is +1 row, same column. Okay. Then we will say new r equals r plus delta r like this, and new column equals column plus delta column. Okay, so now we need to make sure it's a valid square. So this is so R and C is the row and column of a rotten fruit. And this is new R and new C is going to be the positions, 4 different positions above, to the left, to the right, and below the rotting fruit. So if grid of new row, new column equals a 0, then we will continue to the next search, because this means it is empty and we don't care about empty cell. Okay. And same thing, if it is a rotten fruit, we don't want to do anything with that either. So if it's already rotten, so if it equals a 2, then we want to get out. And it must, so we know that the grid must contain only a 0, 1, or 2. So if it's a 0 or 2, we get out. And if we reach this point in the code, then we know it's a fresh fruit. So what do we do once it's a fresh fruit? We turn it rotten. So turn fresh fruit rotten. Or we could say spoil fresh fruit. No, that's more confusing. Okay. So now we want to add this new rotten fruit to the queue. So we will say queue dot append left new R, new C, and minute plus 1. So that's what I was talking about. So like to rot a fruit, it takes 1 minute. Every minute, it also becomes rotten. And then, now this is kind of interesting. I'm not actually sure that we need a visited set here, because in most breadth first search and depth first search, you need a visited set. But in this case, we turn it into a 2. So that's kind of like a visited set because we're making it rotten. So we want to say grid of new row, new column equals 2. So we're going to turn it rotten, add it to the breadth first search, and then lastly, we want to remove it from fresh fruits. Dot remove the tuple, new R, new C, like that. Okay, so I'm just going to return 0 for now, and I want to print I would like to print the grid and fresh fruit just to see what it looks like. Oh, we also have to check, so there's something I forgot. So if we look at minute 3 here, this is a rotten fruit. So when it checks above, new row will be -1, which is out of bounds. So we're just going to, well, I guess I'm going to define quickly a bounded function, which will take in 2 arguments, row and column, and it will return a Boolean expression which signifies if it's in bounds. So the row must be between 0 and the length of the grid, and the column must be between 0 and the length of grid of 0, which is essentially the width of the grid. Okay. So we have here, if it's invalid, we want to continue. So just right here, I'm also going to check first that it's even bounded at all. So if, and then we'll say if it's, we'll reverse the logic. So if it's not bounded, new R, new C. So if it's not in the grid, then we want to get out also. So that should fix that. It seems we have That took a long time. I don't know why. It should not have taken that long. That was kind of weird. Okay, so our final grid is 220,022,022. That looks correct. And our fresh fruit is empty, so that's what we would expect. So what we want to do as our final answer is we'll have max minutes, minimum number of minutes that must elapse until there are 0 fresh fruits remaining. So last minute, most recent spoil, I will say equals -1. And then we want to say most recent spoil equals max of itself and minute. So basically what we're doing is just having this variable here, and then every time we get, so this could be -infinity, which I think I'll make just for clarity, negative, just because the -1 is a return value, so I don't want to get that confused. So if I print, okay, so then we're going to say if length, or I guess we'll say if fresh fruits return -1, else we will return max, what do I call it? Most recent spoil. Okay, so if there's any, so this checks the set length, and if it's greater than or equal to 1, it will, this will be evaluated to true, and it will return -1, which means we still have fresh fruit. Otherwise, it will return the highest minute that something turned spoiled. Okay, wrong answer. My output was -infinity. Does it work if I change it to -1? No. I think it's just some edge cases here. So let's look at, so the grid, so it could be a 1x1 grid. It's just a 1x1 empty cell. So maybe I should make it 0. Okay. So this, in other words, is just if we never, if there are no spoiled fruit at all, or fresh fruit. So if there's no fresh fruit and there's no spoiled fruit, then it should be 0. So I'll just set it to 0 there. Okay, so now I'm curious about something else. So if I set fresh fruit instead as a integer, so if I set it to 0, and then here instead of, so here we'll say fresh fruit plus equals 1, and here we will say fresh fruit minus equals 1, because the reason I'm doing this is I never once used the coordinates of the fresh fruit. Yeah, so we can actually save, we don't need a set there. Okay, so fresh, I don't really need to explain what that is. And I'm going to rename it to fresh fruit count. And fresh fruit count. Minus equals 1. Line 53. Line 66. Down here. So now it'll be, So now, for those of you who don't know, if this is 0, so 0 evaluates to false, and any non-zero number evaluates to true, I believe. I don't know, negative would probably be true. Yeah, so I think it's basically it's asking, does it equal 0 or does it not equal 0? If it does not equal 0, return -1. Otherwise, return the most recent spoil. All right. I'm getting really comfortable with these graph problems. I might try doing some off camera just to kind of get through them. I'm recording this on Valentine's Day, so happy Valentine's Day. Hopefully everybody saw my Valentine's Day special yesterday. But yeah, that's everything. Thank you guys so much for watching, and I'll see you tomorrow.